Hey everyone, and welcome to this video. This is the first in a geometric properties series. This particular lesson is a revision based lesson all about angles and triangles. So we know a little bit about angles and triangles, and the biggest thing here that we can say is about the angles themselves. And an angle is formed. An angle is formed when two lines meet. That's all we need, is for two lines to meet, and that forms an angle. Okay? That's literally it. Okay? Now, we can define a line. We can define a line as a continuous set of points okay, it's just a continuous set of points without breadth or thickness. So a line is literally just a whole bunch of points put in a row. Okay, now the word breadth there obviously means width, as does thickness. And we can define an angle as the difference in direction between two lines. Okay, the difference in direction between two, use the right two, lines. So you can see in our little diagram here, we have this line and we have this line, and they meet up at this point. Now this point is the vertex, and when we have more than one, they are vertices. Alright, so the singular for this word, which is the vertex. The plural is vertices. So two slightly different words there. So you can see that we've formed our angle by getting these two lines to meet up. And you can see that this angle in here that's formed is the difference in that direction. Okay, it's the difference in that direction. That's what an angle is. The angle types, well, there's a bunch of different angle types. We can have acute angles, okay, and these angles are between 0 degrees and 90 degrees. If I put in the right zeros. Fix that one up. That looks better. Acute angles are between 0 degrees and 90 degrees. The next type of angle we have, if we keep going along the line, are right angles. These types of angles are 90 degrees exactly. Then we have obtuse angles. And obtuse angles are between 90 degrees and 180 degrees. I'll just fix up my numbers there. Okay, so they're the three main ones that we're going to be dealing with, but then we also have straight angles, which may sound a little bit strange because essentially that's a straight line. but it's two sections of the line and they meet in the middle, forming a straight angle. These are 180 degrees. And then we have our reflex angles. And our reflex angles are between 180 and 360. And then we have our revolution. Which is our 360 degrees. So we have acute angles, we have right angles, we have obtuse angles, straight angles, we have reflex angles, and then we have revolutions. So there are the different types of angles that we'll be dealing with, and we'll be dealing with them in different ways depending on the problem. Now, these are the base angle types, and then we talk about different types of angles up underneath. So we have 4 more types of angles at a point. Okay. So our first one here, these are 2 angles that are adjacent to each other. So that's a really big thing to remember. These guys are adjacent because they're next to each other. Okay, and these guys add to 90 degrees, or they sum to 90 degrees. And that makes these guys complementary. These are complementary angles. And no, I don't mean they go around saying, hey, you look good. Not that kind of compliment. They are complementary with an E instead of an I. Angles. Complementary angles with an E instead of an I. Next over, we have more adjacent angles. So these guys are still next to each other, but these guys will sum to 180 degrees. So that means they add together to get to 180 degrees, and these guys are supplementary angles. Okay, and at risk of making another bad joke, we're not talking about the extra numbers in the lotto. These guys are just next to each other, adding to 180 degrees. They're supplementary. The third type of angle here at a point, all right, they're still all next to each other. So they're still adjacent. They're still adjacent angles. But this time, they don't add to 90 or sum to 90. They don't sum to 180. These guys sum to 360 degrees. I'll just make my 0 there a little bit better. 360 degrees. And these are a revolution. Okay, so they form a revolution. So that's what these 3 angles together do. Now our last type of angle here, again, this should all be quite revision-like for you. These guys are no longer adjacent to each other. All right, not adjacent. They are no longer next to each other. Okay. These guys are also equal to each other. Okay, and we call these guys vertically opposite angles. These guys are vertically opposite angles, okay, because they are directly opposite each other. Okay. As we're going on in this video, we'll look at some types of triangles now. So we've looked at the different angles. Now we're going to look at some different types of triangles. We have acute angled triangles. So these are the guys where the angles that are in there are all less than 90 degrees. And we can have a scalene triangle. My poorly drawn scalene triangle where this angle will be different to this angle, which will be different to that angle. Same with all the sides being different. So this is the scalene triangle. All sides and angles are different. And the other two types of triangles we can have there, move that up just a little bit. We can have an equilateral triangle. So all my sides are the same and all my angles are the same. So this is the equilateral triangle. And in this one, all sides and angles the same. Okay, and then our last one for acute angled is this little beast where we have an angle in here, we have two different ones down here that are the same to each other, and then these two sides are the same. And make sure that they look different to the equilateral triangle. And this one is our isosceles. Which is probably the hardest of them all to spell. Okay, and this is where we have two angles are equal. Okay, and the two opposite sides are equal. So that's our isosceles triangle. So I'm just going to highlight the names of these triangles. Okay. Now we will come up against these names again, except for the equilateral, but definitely scalene and the isosceles we will come up against again. So in the right angled triangles, we can have a right angled triangle that is scalene. So all the sides are different and all the angles are different. But one of them has to be 90 degrees. Alright, so it always has to include, for a right angle triangle, a 90 degree angle. Because that is a right angle, is a 90 degree angle. Okay, so this is our scalene one. Okay, and then underneath that we also have an isosceles version of the right angle triangle, which fits the same pattern as before. This time we have our right angle in there, and then that angle and that angle are the same, and then that side and that side are the same. So this is our isosceles. Again, one of the harder words to spell. Then we have our obtuse angles, and our obtuse angles has to have at least one angle one angle must be greater than 90 degrees. If the other angles are greater than 90 degrees as well, it can't be a triangle anymore. And we can draw in another scalene, but where one of those angles is greater than 90 degrees. Okay, and that's our scalene again. And then we can still have an isosceles, which look very similar to my scalene that I've just drawn. I should have probably drawn my scalene a little bit different. That's okay. Markings will make it look right. There we go. There's our isosceles obtuse angled triangle. Okay, just a couple more things before we finish this video. The angle sum, you do need to be aware that the sum of the angles in a triangle is 180 degrees. So the three angles of your triangle must add to 180 degrees. Okay, so we can even track a little diagram in on that. All right, we can call this A, B, and C. So A plus B plus C must equal 180 degrees. And my last little bit for this video itself are the exterior angles. So what do you need to know about exterior angles? An exterior angle is formed by extending. So that's making one of those sides longer. We are extending one side of our shape, one side. Okay, so what we're doing is we've drawn a triangle. Okay, so there's my triangle. And to get the exterior angle, so I've got A and B and C in here, but I want to make a exterior angle. So I'm going to take this side and I'm going to lengthen that line. And then in here, well, that's my exterior angle. And I'm going to make that one D. Now, the exterior angle is actually equal to the sum of the two opposite. To the sum of the two opposite angles. So what I mean by that is that D is equal to A plus B in this instance. Now that's all the theory for angles and triangles that we are going to cover in this lesson. Please head over to the next video for the examples.